The way the bubble sort works, it essentially just compares adjacent cells working its way down an array, and it decides whether or not the contents of the two cells need to be sorted. We're dealing with integers here, so it'll be easiest to wrap your head around what's going on. All right, so it may be that I want to sort this in order from lowest to highest. Okay, so what I'm going to do is I'm going to look at these two cells and I'm going to say, is 8 lower than 5? If it is, then I'll leave it alone. But if it isn't, I'm going to swap them. Then I'm going to look at the resulting array, and I'm going to say, is this slot bigger than this slot? And in that case, it would be an 8 and a 3. Is 8 bigger than 3 or less than 3? And the answer again would be no, so I would go ahead and swap them. So what I did was I wrote a program here that kind of demonstrates this bubble sort. Now, mind you, you're going to see an immediate problem as we work our way through this, all right? This portion of the code that we've written is actually good, valid code. We will be using it, but it's going to expose another issue, okay? So let's go ahead, first of all, and let's take a look at the code. You'll notice that right off the bat, I have swap. There's my function up there called swap. And you'll see that down here, I have swap, okay? And here I say, if A, the first cell, is greater than the second cell, then I want to swap it. And then after that, I have just tons of printing messages. For example, up here, for K in the range of the length of our array, -1, and I'll tell you why that is in a second, we're going to store in a temporary variable. We're just going to get some input so that I can stop the program or pause the program. Hit enter to continue to the next step. That's all this line of code does. All right. Then I take A or K, whatever K happens to be in the moment, and I just stick it in first because that's the first index that we're looking at, and in this case it would be 0. And the second index is going to be equal to K plus 1. All right. So that's the second one we're looking at. In other words, we're looking at this placeholder, this element, and then we're looking at this element, these two next to each other. And then I put a little message in here and I say I'm looking at array elements, blah blah blah. And then down here I make the test. And if I do a swap, I send the message that I swapped the elements, the contents of the elements, and you'll see that in a second. And if I don't do the swap, then I say that I'm skipping the big handy dandy swap. And we're going to notice something now really quick. All right, so let's go ahead and let's run this. Maybe it'll run, huh? Oh, I ran the wrong program. So let's go ahead and go over here and we will run bubble sort step 1. Run that. Okay, and it says hit enter for the next step. So what I'm going to do is move my cursor there so that I can see it, and I hit enter, and it says I'm looking at array elements 0 and 1, and there's 0 and there's array element 1, and we see that 8 is bigger than 5, so it's giving us a message that it's swapping 8 and 5. Hit enter for the next step. Now we're looking at elements 1 and 2. There's elements 1 and 2, and sure enough 8 is still bigger. So it's swapping 8 and 3. So do you see what's happening here? The number 8, if you will, is percolating in this direction. Or in other words, it is bubbling in this direction. And that's why they call this a bubble sort. Because bubbles move up through the array. All right, and so we're going from the 0th element to the maximum element. And we're taking the biggest numbers and we're moving them up through the array. All right, so yeah, that's going to work. It's going to do its thing. So I'll hit enter again. And it says it's looking at elements 2 and 3. And it says that it's going to swap 8 and 1. And then here we end up comparing 8 and 9, so it skips it. It leaves 8 and 9 alone. We go to here, it's going to compare 9 and 6, so it's going to swap them. And so now 6 is in this spot and 9 is in this spot. Okay, we hit enter. And now it's comparing 9 and 0, definitely going to swap it because it says that it swapped it, right? And then here it's swapping 9 and 7, and as you can see from the array, there's where 9 is. Now 9 is over here, and in a second 9 is going to be over here. Do you see how the 9 is percolating up through the array? And we just keep doing this until finally we are done. It says that we're done. Okay, so is the array sorted? It's not, is it? this array is not sorted at all. So this is a problem. One loop is not going to get the job done. But if we carry our thought a little bit further down the road, we might realize that, well, I've got this many, I have this many elements. What if I put an outer loop that just simply does this bubble swap, if you will, 9 times or however many times the length of this array is, okay? In this case, 10. What if I do that? Well, what's going to happen is by brute force, it's going to sit here, and it doesn't matter where your highest element is, it is going to force that element to all the way end up on this end, and ultimately the next runner-up will be here, the next runner-up will be here, and so on and so forth, okay? This is the bar none most inefficient way of doing a sort. So let me go ahead and make the change in the code. I'm going to put a little loop on the outside of all of this so that we can get the actual critter happening. And I'm also going to get rid of all of these let's see. I'll get rid of a lot of these printing statements, okay? And then we can compare the arrays as we go based upon the outer loop. Okay, I've made my changes, and as you can see, this down here hasn't changed a bit. But this up here seems to have changed quite a bit. In truth, it really didn't change hardly at all. All I did was get rid of all the print statements. And since I was using else in order to print the fact that a swap did not occur, I went ahead and removed else as well. Okay, so let's have a look at it. Here's our original loop that does the swapping for one single pass on the array. Okay, there's again first and second. If a sub first is greater than a sub second, then swap them. Okay, first and second. Down here then I have it inside a larger loop, and it says in here for I in range length of a. So it's going to go through this thing 10 times because the array is 10 elements long, right? And what it's going to do is it's going to do the inner loop, and when it's done doing the inner loop, it's going to stop for user input, and then it's going to print a. And I think what I'll do is I will move this actually after the print statement. There we go. And get rid of those extra lines. Alright, so there it is. Let's see what happens. Let's make sure this thing even runs. We'll hit the run button, and it says there's an array. Now remember, if you will, how this thing was to begin with. Remember, we had an 8 and a 5 that was here, and it did the swap, and there was an 8 and a 3, and it did the swap, and so on and so forth until it encountered the 8 and the 9, and it did the swap, or it didn't do a swap, right? It skipped it. So then the 9 bubbled its way all the way up until it finally made it to the end. All right, so looking at this array, what would you think would bubble all the way up until it makes its way to maybe this spot here? Because of course 9 is the biggest number we have, right? Well, if you said 8, you're right. Okay, so let's go ahead and let's hit enter and look at the next step. And as you see now, 8 has bubbled all the way up. Isn't that cool? That's why they called it a bubble sort. Now mind you, testing to see if these two needed to be swapped in a sense was kind of a waste, because we already know the last two positions are exactly correct. So there's a way of writing it in, you know, that you keep shortening the I range here until you run out of array, basically. But I'm going to make this easier on you guys. I'm just going to let you use the brute force method. Alright, so there we go with this. Some of you guys are saying, well, wait a minute, where are we going to use this? Well, I'll explain that here in a second, but I need you to make sure that you understand what's going on with a bubble sort. So we're ready for the next step. Hit enter. We're looking for a 7 to show up, right? So these over here might change, right? Is 3, you know, we have a 3 and a 1 here, and we have a 3 and a 1 here. Are these going to swap out? Are these going to swap out? Let's have a look at it. Okay, I'll hit enter, and we see that yes, the 3 and the 1 swapped out. We have a 3, we have a 5. Things bubbled up until ultimately we ran into the 6 and the 7, right? Which in turn bubbled up until we finally received our 7 here. Okay, looks like 5 is in there a couple times. I didn't even realize that. Alright, so hit enter to get the next step. I just grabbed random numbers. And there we are. There's 6, and there's 5. Here we had 7, here we had 8. So we picked up the 7 here, and now we have the 6. Here we did the 9, we did the 8, we did the 7, we did the 6. Now it's time to look for the 5, and that's what it's going to do. Maybe, maybe not. Let's see. We'll hit enter and see what it does. So we had 5, 6, 7, 8, 9. Here we have 5, 5, 6, 7, 8, 9, and that is in fact correct. So now we're looking for, out of this list, we need a 4 to be in this position. So we hit enter, and there we are. 0, 1, 3, 2, 4. Looks like we're almost done sorting this. 0, 1, 2, 3, 4, 5, but are we done with the actual loop? 0, 1, 2, 3, 4, 5, etc. Still not quite done with the actual outer loop. It's going to keep running until finally we are finished. So in truth, because of the way the array was running, we ended up running that outer loop 4 extra times. Okay, that was all because of the way the numbers fell within the array. Hopefully that makes sense. Alright, so the next segment of the video I'm going to talk about what your actual assignment is.